Hello everybody, this is Mr. Carey coming back to you with another GoMath 4th grade lesson, and today we are going to leapfrog or piggyback or whatever term you want to use off of lesson 4.7, which was using repeated subtraction to do division. And I was looking back at the lesson for 4.7 and realized that it can get kind of tedious, especially when you get to the bigger numbers of subtracting the divisor from the dividend over and over and over and over and over again. For the smaller numbers, it's not too bad, but when you get to the bigger numbers, like we're going to do in this example, you generally don't want to spend all of your time subtracting. But it's a really cool strategy to show you how division really works. And I was explaining in my class today that division can be somewhat of an abstract, idea, especially long division. We may in our mind know, if I say, I'm going to do a small example here. If I do, I'll do it in blue so we know it's not really this question we're doing. Let's say I have 11 crayons. Okay, I have 11 crayons. And I want to make groups of 3 for whatever reason. Like I want each group to have 3 crayons. Okay, how many crayons? Or how many groups of crayons would I have? So again, this is a little easier to think of, right? Like, okay, I know what 11 crayons looks like, and here I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, there's my 11 crayons, and I want to make groups of 3. So how many total groups am I going to have? Well, this is fairly easy because we can look at this and go, yeah, all right, groups of 3, and I'll just draw it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that's all I can do, and I have 10, 11. So how many groups can I make? Well, I can make 1 group, 2 group, and 3 groups, and I have 2 left over, so I have a remainder of 2. What would that look like in division? Well, if I do it, on the division way right here, well, how many groups of 11, how many groups of 3 do I have in 11? Or a better way, 3 times what gives me 11? Or gets me close to it, right? Well, 3 times 3, sure. 3 times 3 is 9. And then 11 minus 9 is 2, and I have my remainder of 2. Now, this is, again, fairly concrete. We can look at this and go, yes, I know in my mind what 11 crayons looks like. Groups of 3, sure, I've done that before. So this isn't terribly difficult to think of. But when you start getting to bigger numbers, like 125, there's even some where it's like 674. How many people have seen 674 of anything? It can be very, especially 4th graders or 5th graders, it can be very difficult to really conceptualize or think of what that means. So repeated subtraction works, but we're going to jump to 4.8, which is taking what we learned in 4.7 with repeated subtraction. And we'll go back to the crayon example, right? Just to recap. All right. So with repeated subtraction, I take my divisor and I subtract it from the dividend. So 11 minus 3 is 8, and then I keep track over here. It's 1. 8 minus 3 is 5, that's 2. 5 minus 3 is 2, and that's 3, and I have 2 left over. So that's exactly the same answer we came up with. So for this would be easy to do repeated subtraction, and it wouldn't take up all of our time. But let's use this example, 125. So let's read, and I'm going to highlight kind of the information that we really need. And this is a great strategy. I'm going to highlight what I'm asked to find, and then I'm going to highlight kind of what do I need? What do I need to use? Okay. So there are 5 at camp. There are 5 players in each lacrosse team. If there are 125 players on lacrosse teams, how many teams are there? Well, we know we're going to need 5 players, right? We're going to need that number, and it's nice. There's only 2 numbers, so I have a pretty good idea of which 2 numbers I'm going to use. And then 125 players. Okay, Great. So what is that going to look like, though? Well, what they're asking is, I have 125 players. I have one group of 5. I want to make groups of 5, or teams of, whatever you want to call it. Teams of 5, groups of 5. Well, how many teams or groups am I going to have? So, if we write it out, let's start here. 125, remember 125 players. I want to make teams of 5. How many teams am I going to have? Right? That's what it's asking us, and that's division. So this can be a little harder to think about it, right? And do I want to sit here and go use repeated subtraction? 125 minus 5 is 120. 120 minus 5 is 115. I mean, we're going to be here probably longer than than I can record on my iPad. I may run out of memory soon. So I don't want to do this. There's got to be an easier way, and fortunately there is, and it's called lesson 4.8. So let's look at what that looks like. So I can take, and this is a key term, which we already know, factors. I apologize for my handwriting. I'm writing kind of awkwardly on the iPad. I'm using factors, okay? And so what I'm going to do is say, well, what are my factors of 5? Right? How close can I get close to 125? Because I don't want to subtract 5 over and over and over again, right? And remember my factors of 5. 1 times 5 equals 5. 2 times 5 equals 10. And then 15 and 20 and 25 and so on, right? Those are my factors of 5. So I'm going to use those to speed up my subtraction, to speed up my division with repeated subtraction. But we're not going to call it that. We're going to call it partial quotients. And what I'm going to do is I'm going to highlight my divisor. Oh, maybe I'll just write over it. All right, I'm going to highlight. There we go. That's better. I'm going to highlight my divisor, and then I'm going to highlight my partial quotients up here, and you're going to see why in a minute, right? So let's do this. Instead of subtracting 5 over and over and over again, let's think of a number that I can do that's going to kind of chip away at this, right? I want to take this 125, I want to get it smaller and smaller and smaller. So what number do you think comes to mind? Yeah, I mean, I think that would work. If you said 5 times 5, right, 25. That's staring me right in the face. That's just begging for that to be gone away. So how do we do that, right? How do we make 25? Well, 5 times 5. Now, check this out. I'm going to highlight my divisor. I'm going to keep them the same color. I'm going to highlight in, we'll do blue, my partial quotients. Now, actually, let me erase this and change it to blue, because I'm going to make that blue. This is where my partial quotients are going to go. There we go. That's better. Okay. So, 5 times, let's get back to it. 5 times 5 equals what? 25. And I subtract that. 25 from 125 is 100. Now, before we go on, I'm sure some of you are saying, whoa, where did you get this 5? Like, you just came up with that? Well, how does this work? Well, I'll show you. We'll do this the long way. 125 and 5, okay? I'm going to subtract 5 from 125. And I'm going to do it until these numbers match up. And I'll show you. 125 minus 5 is what? 120. 120 minus 5 is 115. Oh, sorry, I got to keep track. 1, subtracted twice. 115 minus 5 is 110. That's 3. 110 minus 5 equals 105. And that's 4. And then 105 minus 5 is 100. How many times did we subtract? We subtract, and I'll highlight it. We subtracted 5 times. Well, look at this. This number and that number are the same. That's partial quotients, right? I don't want to subtract, 5 times 1 is 5. I don't want to do that, a bunch of times. So I come up with a number, and it's just, this is where I think some of the students maybe struggle with is, well, tell me exactly what number to use. Well, I don't know. I mean, whatever number is easier for you. And remember the key word, one of the key things we're learning in multiplication and division in Common Core is mental math. And I'm going to, just because I can, I'm going to go draw a little bit of a light bulb here. And I'm going to go mental math, right? Whatever math that you can do in your head that makes it easier for you to come up with, right? If 5 times 5 works for you, do that. If you know your multiplication tables up to 25 times 20, fantastic, do that. But this is where Common Core is awesome because some people know their multiplication tables really high, and some are still kind of learning the 9s and 10s. So do what works for you, right? So let me erase my awesome drawing. So now that we're at 100, let's keep going, right? Now, if you want to keep going, 5 times 5 is 25. You can do that. That's chipping away. But let's see if we can get a little bigger, right? Let's start with, maybe do 10, right? So let's do that. 10 times 5. And what is 10 times 5? 50. That's correct. And let's do my highlighting, right? Remember, these are my partial quotients. This is my divisor. All right, cool. 100 minus 50, 50. And then now, guess what? We can do that over again. We need to get to 50, right? There's 50. How do we get to 50? Well, 10 times 5. Sure, we just did it. So let's do it again. 10 times 5 equals 50. And I'm going to put a little 0 there. And check this out. We have no remainder, which is awesome. Now we're not done. We have to add up our partial quotients. And our partial quotients, remember, are in blue. So I have, these are my partial quotients. Now, if you can do this in your head, great. If you can't, feel free to come over here and do 10, 10, 5 plus 0 plus 0 plus 5 is 5. 1 plus 1 is 2. And check it out. Our answer is going to be 25. And that's our answer. So how many teams are there going to be? Well, there's going to be 25 teams of 5 players. Okay, that's pretty cool. And this is why I like partial quotients. And this is what I was telling my class today, is I really wish they had come up with this, when I was going to school, way back in, the 80s, when everything was black and white and cars weren't invented yet. It was just it's just a very cool thing. And I'm going to show you why I wish we would have had it. Because with these smaller numbers, right, hundreds, 125, it's pretty, it kind of like, yeah, Mr. Carey, I can go either way. Well, what happens when I get bigger numbers, right? And I'm gonna throw a huge number on there. And I want to do something with a remainder. Because I think we understand if I have a number and the divisor goes into it equally, that I have a 0 and boom, there's my answer. Well, what happens when I have a remainder? Okay, well, let's do that. And we'll start a little bigger. I'm not going to scare anyone yet with like really big numbers. I'm going to take something from the book. And this is on, if you're following me and you have the book in front of you, page 175, chapter 4, and this is lesson 4.8. So I'm going to take number 5, but I'm going to change it a little bit, right? So the answer they have, right, the question they have is 259 going into 7. Well, I know that's going to come up with an even, there's not going to be a remainder, right? And so I want a remainder to kind of show you what that looks like. So let's change that. Let's flip that, and we're going to change that 259 to 261, because I have a fairly good feeling that that's going to come up with a remainder, and that's what I want. Okay, so let's do our partial quotients. And so probably some of us are looking like, okay, so what do we do? Well, remember lesson, I think it's 4.5 or 4.6, we talked about basic facts, right? Taking numbers and making them basic facts and getting them to work, right? So let's do that, right? 7 into 261, that's super abstract, super like, I don't know. Well, okay, ignore ignore the 261. Focus out, and I'll shade in my this, do this, stay consistent here, right? Fine. That's weird and abstract. Okay, well look at that, then ignore that. 26 and 7, that's what I want you to focus on. Now that is a little bit easier. That you can, okay, 26, got it, that's a basic fact. Well, 7, and this is what it'll look like, 7 times what gets me 26? Or if I can't get to 26, how close can I get? Well, okay, if you said 4, I like where you're going, right? 7 times 4 is 28. The problem is it's going to be too much, right? I can't go over. I don't know how many fourth graders out there watch The Price is Right, but remember, you want to get closest to the price without going over. Some of you parents who are watching this, you may understand. So I can't use 4. Fine. Let me do a big, can't use 4. Well, what can I use then, right? Well, if 4 didn't work, let's do 3. 7 times 3 equals 21. Cool, I can do that. But remember, I don't want to just use a 3. I need to get to 261. So what would this 3, what could I do to make that 210? That's right. 7 times 30 gets me 210. Awesome job. That is absolutely right. So let's use that. All right, I'm going to erase all this. It's just going to get in my way. And let's change it back to my black pen. Erase my underline. Okay, so we've agreed 7 times 30. So what I'm going to do is I'm going to put 30 times 7. Now remember, here's my... keep forgetting to put the highlighter on. 7. There we go. And there's my divisor. And we're going to do blue for my partial quotient. So 7 times 30 is what? Well, yeah, we agreed it's 210. Cool. Well, let's subtract it now. 1 minus 0 is 0. 6 minus 1 is 5. All right, we're getting there. Now this is within our 7's times table, so we could probably come very close to this. So what do you think we should do? 7 times what gets me close to 50? Because I know 50 is not a factor of 7. 7 times what gets me close to 50? Yeah, 7 times 7. So 7 times 7. And let's go ahead and highlight it red. That's my divisor. Highlight that blue. That's my partial quotient. 7 times 7 is 49. Cool. And now what? Well, we have to subtract. 50 minus 49 gets me 1. So, can I go anymore, right? So I still have a number here. I still have the number 1. Can I go anymore? Can I make this any smaller? Well, the answer is no. I mean, not without going into a negative number, not without having a decimal. And I don't want to do that right now. Now, we'll learn that later, how to do decimals. I don't want to do that right now. So I'm done, right? I'm going to circle, I was going to circle that. There you go. I'm going to circle that. And that's my remainder. Remember, that's if I have 261 of something, I'm making groups of 7. How many groups can I make? Well, let's start by adding up our partial quotients. 30 plus 7 gets me 37. Cool. Now, what do we do? What do we do with that 1? Well, what we're going to do is that 1 is going to go, depending on how you want, it's my remainder. So all I have to do is put a remainder of 1. Now, I gave my class a little pop quiz today of, okay, well, I can't use remainder 1. Make this into a fraction. So I want you, if you follow me at home or you got paper out, I want you to show me, if I was like in front of you, what that remainder would look like if it was a fraction. Okay, I'll draw the fraction thing here for you. Now what? All right. So if you said the remainder goes on top and the divisor goes on the bottom, guess what? You are correct. It's pretty cool, huh? So that would be my answer, 37 and 1/7, or 37 with a remainder of 1, whatever you'd like. But that is how you divide with partial quotients. And I'm going to do one more, and so I love doing this to my class, because every time I throw like a huge number up there, I do it purposely to kind of, show them that, look, you may look at a huge number and it may like, oh, I can't do that. Well, again, I tell my students, how do you eat an elephant? One bite at a time. Well, if math were, that saying, it would be, division with repeated subtraction. So we're going to eat several bites at a time, and that would be dividing with partial quotients. So let's take a big number, and I did one today, and I usually have the students like, give me a 3-digit number. And one of them said 999. I said, keep it 3 digits. I don't want to get into the really huge numbers yet. So let's do that. 999, and give me, a number between 3 and 9. Yeah, I'm going to do something I know will not, I know we'll have a remainder. And let's go ahead and do, I don't know, something a little tougher. Let's do 7, right? No. We haven't done 8 yet. All right. So let's do 8. Now this, if you're looking at this and you instantly are like, ooh, that's too hard. Remember, I'm not asking you to solve it all right now. We're going to use partial quotients. So let me set up my divisor. There's going to be my partial quotients. All right. So let's go ahead and start doing our partial quotients. So the first question I'm going to ask you is, how close can I get to 999 with 8? Now, I mean, if you're like, I don't know, Mr. Carey. Well, start off with, can I get to 800, right? 8 times what gets me 800? And you're like, oh, dude, that's easy. That's 100, right? 100 times 8. Well, there you go. I don't care if you say, well, I don't know, I'm just going to do 10 times 8. Fine, right? Start with that. But let's do 100 times 8. We want to go big here. 100 times 8 gets me 800. So let's go ahead and highlight my divisor. Highlight my partial quotients. Perfect. Now, 100 times 8 is 800. Subtract 800 from 999. 9 minus 0 is 9. 9 minus 0 is 9. 9 minus 8 is 1. All right, we're getting there. Now you're probably like, well, what do we do? Remember, basic facts, right? Don't look at the 199. Look at 19 and 8. 8 times what gets me close to 19? Sure. If you said 8 times 2, and remember, is it 2 or would it be 20? That's right, it would be 20 because I need to make 180. So remember, I'm ignoring this little dude right there, but I need to like kind of not ignore him at the end. Once I figure out my basic fact, then I got to say, okay, yeah, I'm not ignoring you anymore. So 20 times 8. Cool. Let's do that. And let's see what that gets us. And highlight. Perfect. Okay, 8 times 20. So 8 times 2 is 16. 8 times 20, or 8 times 2 tens, going back to Common Core terminology, 8 times 2 tens gets me 16 tens. And then, yeah, I'll probably, there we go, erase that dude. Now we're getting somewhere, right? So 164 from 199, 9 minus 0 is 9, 9 minus 6 is 3, and we're getting closer. So I will ask you probably one more time, how many times can 8 go into 39? Or 8 times what gets me 39? Or how many groups of 8 do I have in 39? You know, all three of those totally work. Well, if you said 5, like again, remember Price is Right rules, 8 times 5 equals 40. So unfortunately, that's just going to be a little too big for us. So get rid of that. So if 5 didn't work, well, what about 4? Sure, I think that'll work. So let's put our 4 here, times 8. Cool. So 8 and 4, perfect. 8 times 4 gets me what? Gets me 32. Awesome. And now we can just subtract, right? 9 minus 2 is 7. And look at that. Can we make any more groups of 8 from the number 7? No, we can't. Again, not without getting into decimals or fraction. I mean, and we're not messing with that right now. So leave it alone. That is going to be your remainder is 7. So our job isn't done. We now have to add up our partial quotients. So 100 plus 20 plus 4. And the cool thing is, it's just, you just go down 124. 124, and I have my remainder of 7. Or, you know, if fractions are your thing, let's go ahead and do that then. 124 and 7/8. And you are done. So that is dividing with partial quotients. And I really think it's kind of a cool concept. Only because when you get to the larger numbers, and I remember, one of the few things I remember about 4th grade is just feeling kind of, when you get to these big numbers, not fully understanding why I'm doing what I'm doing. And that maybe is a common complaint. But I distinctly remember just, okay, and I don't want to show you the wrong way or like the way I used to do it, because I really do like this way. And I'm not just saying that because I'm a teacher and because, you know, I have to believe in Common Core. Like, no, I actually do think this is a great way to show people how to do division. You know, in the old ways, it was like, how many times can 8 go into 9? You do it place value by place value. And we're going to get to this. It goes into 1. 1 times 8 is 8. And then bring down the 9. And you just do it place value at a time. Well, again, if you don't understand why you're doing that, it just doesn't really make sense. And you're just doing the steps, but you're not understanding why you're doing what you're doing. So that is the beauty of dividing with partial quotients. So if there's any questions or comments or concerns, or you just want to say, you know, hey, you did something wrong, or hey, we'd love to see more of that, or, you know, show me whatever you want to, I'll throw it on YouTube if I can. Don't ask me for any pre-calculus or calculus, because it's been way too long, and I don't want to do that yet. 4.9 is coming up, should be coming up tomorrow. Actually, I'll be teaching it tomorrow. So a little preview. 4.9 is, we're just going to model it, but division with regrouping. It'll be pretty cool. It'll be a good lesson. So this is Mr. Carey signing off. Again, any questions, comments, concerns, leave a comment in the block. Like this video if you like it. Give me a thumbs down if you don't like it, if you think I'm totally wrong. But I would appreciate you telling me why I'm wrong so that I could fix it. Don't just give me a thumbs down because you don't like my voice. Because I already don't like my voice. I don't need anyone else not liking my voice. Anyway, a little bit of self-depreciating humor there to end my 4.8 lesson. So this is Mr. Carey signing off, and I will see you all tomorrow. Bye.